to as well. So please do let me know. Hope you all can see my screen. Okay, I'm assuming that everyone can see my screen. So this particular problem actually yesterday that which we have discussed it, and the same thing that I'm just going to explain here too as well in detail. So the supporting code actually I've just kept it here. So you can just use simply copy this and run the commands. And the document related to this I have also enclosed here for this. So this is where, as I discussed with you yesterday, the problem here is like there is already an existing building and which is supported with some piles, and below that particular piles if there is a tunnel construction going on, and because of this particular tunnel after that how it is going to be behave is what we are going to study this actually. So for that particular thing that we need to do all these things, so the tunnel constructions that we need to study this. So the two ways, if it's already tunnel is there and then if you would like to construct the building, then what will happen to the tunnel, you can study it in this particular problem. The other way around that we were doing it now, it's already a building is existing it. If we are going to place a tunnel below that particular building, what is going to be happen is what we are going to study now today. Okay, so moving on to this, as usual, if you would like to see the borehole properties over here, this is where we are going with the 4 different soil layers, and in each soil layer is having this thicknesses and the water level that presently as per the axis that I am just assuming that it is like a 0. Okay, it is like a 0 because my axis is starting it over here. Okay, it is exactly at 0 positions. Okay, and if you would like to see what are the material properties and all, you just put always go for the control M2 as well to see the material properties. And if you just look for the clay it is like a morcolum, undrained B, and then you have all these particular material properties and all. So it's a MC model. Now slowly we were coming to the realistic. And the first 2 examples that you have seen like an undrained drain models of hardening soil, all those things. But in majority cases, we will follow only the morcolum model. Yeah. So the parameters that is like an Young's modulus, Poisson's ratio, and coming to the strength that you are providing here, cohesion, friction angle, and latency angle. Okay. So it's all like a general material properties only that you are feeding it. I just got into the new version of Windows, so that my whole thing still I could not able to recover that particular part. So I'm just saying this. I lost all this particular materials. I'm just selecting this particular thing. Okay. Now in this actually, if you just look into this, this is where the structures module that I'm doing it. So now into the structures module, if you see that. So the first thing actually what they have done, they have just created these particular files. They have just created these particular files. You know how to create a file. So you are just going for this create a line, and there you have an option called as created embedded beam row. If you select this particular create an embedded beam row, and this is how actually you can able to create the files as you needed. Okay, this is how you can able to create the files. Okay, now what is the material properties of the files that they're buying? That we will see that actually. So what are the material properties that they have taken is like, so you have to go for the control M again. And in the soil, if you just go for this particular embedded beam row, these are the foundation files that we have it, which I'm saving it to as well. And if you would like to edit this particular foundation file actually, so this is where the material behavior type I'm selecting it as an elastic. If you have like an plastic material properties also beyond the Hooke's law, that if you would like to study, even you can able to pass on your elastoplastic material properties itself. And if you have any particular MK model also with you for plasticity, even that's also supportable. Okay, so you can just select this as an elastoplastic MK material model also based upon the material properties that we have. Now, if you select this an elastic material properties, which is the basic one that I'm going it. Now here you would like to provide the Young's modulus of your material, and then you have to provide what is the strength of this. Okay, I mean to say that so this is nothing but your density that you are feeding it over here, mass by volume that you are feeding it. So what is your Young's modulus and what is the density of your thing, so that you can able to provide this mass by volume, and then you can able to provide this mass by area of this. Okay, and then the beam type actually. So which type that you would like to prefer? It's a predefined one or the user defined one? It's a predefined one, massive circular beam with a diameter of a 0.25 meters. So the piles, the foundation piles, what I have selected, so it is having a diameter of around like a 0.25 meters. Okay, so and then I have like automatically the area is going to be calculated because you are providing the circle and diameter. Pi r square it's going to calculate it. Okay, and then inertia also it's going to be calculated. So the L spacing, as we have discussed in the old classes itself, we know that this to the foundation, the backend spacing is around like a 3 meters on this. Okay, so the similar properties that we are going for the other piles too as well. So we were just simply assigning these two particular piles. After this, actually, what we have done is simple. One particular plate element that you are considering it, and to this particular plate element actually you are assigning your building material properties actually. Okay, so what is that particular plate? If you go here in the plate, actually you can able to see that there is a building. So this is what is the building material, and the lining and the TBM is nothing but our tunnel material properties actually. Somehow I'll just save this to as well. Okay, so if you just go for the building material, if you just see this, these are the material properties that I have just provided for the building as a plate. Similar to that, Young's modulus into area 1 that you are dividing it, and then the E into inertia values that you are providing it, and automatically the thickness it's going to be calculated for that too as well. And then what's strength of this particular thing, it's going to be provided by this. So this is nothing but your yield stress, or like or people depends upon that. Would you like to go for an yield stress, or you would like to go for a fatigue stress also, endurance limit also you can able to provide this. And if there is an Poisson's ratio, that you can able to provide this particular Poisson's ratio to as well. And any damping of your material, you can provide the railing alpha and beta values to as well. It's simple. So we already know that how to create a material properties. We have already seen that. That's why I'm just going in a fast way. So this is where it includes the complete building material properties. Okay, it is just an assumption, guys. Instead of building the whole construction of the 5-story or 10-story building, that we were just using that particular plate element as a building, and this particular load will be distributed to these particular piles actually. Okay. So after this, actually, in yesterday's class that we have seen that how to create a tunnel too as well. And this is where actually we were creating a tunnel. And you know, to edit this particular tunnel, we can't do anything over here. So for that, you have to expand the tunnels. There is a tunnel one. Right click on this and you can just go for the edit. So if you click on this edit tunnel, as we have seen in our yesterday's classes, if you just go for the general, this is the circular one, and they are defining only the right hand half. And what is that? They are going on offset distances actually in the axis 2. That's around, that's where from the 0, it is deviating for minus 0.2. So exactly center would be like 0, 0, they were considering it. Okay. And going for the segments, actually, this is your segment. And where to this particular segment, they were providing the radius to as well. And the radius is like 2.5 meters. So that means the diameter would be like 5 meters of this. Okay. Okay, tunnel radius, everything that you have fed here. And then you have to go for any subsections if they are doing it. Right now, they are not doing any subsections. Now we can just go for the properties of this. So the general properties, if you select this, we have something called as a negative interfaces. That is where like inside to this tunnel boring machine is going to remove all the soil. There is no interactions between the soil and to your tunnel components. So that's why there is only an interactions in the outer side of your tunnel. So that's why only in the outer side that we were taking the negative interface connections and all. So you have like a negative interface connections to the outer side of your tunnel and all. So this space is going to be an empty, and this space is going to be like interactions with your soil, and that's where actually it is coming over here itself. This is where like this particular soil we are going to remove this, and this particular soil is nothing but in interactions with your tunnel outside. So that's why I'm just going only with tunnel interaction. I mean negative interface I'm going with, so that you can able to see these things. Yeah. Next, moving on to this. This is one thing. The other things is like, excuse me, guys. The other thing is like the line concentration. Yesterday we have seen only up to like how to create a negative interface or something. So what are all the best possibility ways that we can able to create it over here? That is what you can see this. Right click here. You can just go. You already created that as a plate element. You already created as a negative interface, and you can create a line contraction also. You know what do you mean by a line contraction? Like during the tunneling process, actually, um, when you're just going for the tunneling things and all, you need some sufficient amount of a pressure that to be an applied, so that the deformations of the settlements of the soil will not come down. So for that, actually, we are just going to maintain that by changing the cross sections area of the tunnel from the starting to the end, and that particular deviations is like by 0.5% actually extra pressure that we are going to apply for this particular things and all. So this where actually the soil will be applied under some pressure, so that till then the lining comes and sitting over there. So this particular pressure will support you to avoid this particular any damage to this particular soils and all. Please be remember that how a real tunneling construction process works on it, so that will really help you out. So I have some videos for this too as well. This is a good one actually, with some explanation over here too as well.
This is Jules, VP of a ketchup company, about to.
एक बार फिर से स्वागत है आप सभी का। इस वीडियो में हम बात कर रहे हैं कि किस तरीके से टनल बनाया जाता है, रोड के लिए, ब्रिजेस के लिए, मेट्रो के लिए, रेलवे के लिए, किस वेट कर लेंगे। अब ये डिपेंड करता है, ये हमने बना दिया है, आगे प्लेस होना चाहिए, पूरा सॉइल बाहर निकाल लेंगे और आगे चल के अंदर तो पूरा क्या किया हमने, पहले हमने में जान जाती है तो
Hello, hello.
I think system was struck.
Screen froze now.
Hello?
Hello.
Vivek.
Did screen freeze?
I am not listening.
I am saying it's hanged now.
Yeah. నా అశోకన్న ఫోన్
Just
పవర్ పోయిందంట మొబైల్ నుంచి కనెక్ట్ అవుతుందా భరత్
కనెక్ట్ అయ్యింది.
అదే మొబైల్ నుంచి కనెక్ట్ అవుతుందా అండి పవర్ పోయిందండి
Hey, sorry guys, I had a power shortage here. Okay, I hope you all can hear me, right?
Yeah.
Okay, fine. Yeah, I think you can see my screen too as well. So
होते जाता है, लेकिन ऐसा होगा तो घर भी गिर जाएगा.
just go for this actually. Yeah. So whenever you can see this one, actually the machine is coming and then it is excavating all your particular soils and all, and later on actually that it need to go and it need to insert this particular prefabricated plates in this whatever it is coming it over here. So it has to be inserted these particular plates over there, and in these particular holes actually that we were going to grout it. In this particular cases, what will happen, inside that we don't have any soil, but outside to this actually there is an interactions with the soil actually. So to provide that particular interactions only, that we were giving a negative interface over here. Okay, second thing, for this actually the negative interface for the soil interactions that we were going it, and when the plates, before placing up these particular plates actually, before just placing up this particular plates, when the machine is moving in the forward directions, actually what will happen when there is a no machine, the soil may fall actually. I can able to capture that. So the soil may fall, or it can be stopped it over there at, this is an excavation process. So this is where actually some places actually the soil may fall down, and just to avoid this particular things actually we are going with one particular thing called as a line concentration, so that this particular tunnel and machine itself will help you out to avoid this. So that's the reason actually your tunnel boring machines will be always having a connectivity of like 0.5% deviation. So this is where that you have it. And the other things is like the plate elements. So I need to make sure that there is a tunnel machine available, right? So I would like to mention that there is a machine available and that particular machine is doing some particular process and all. So how do I tell that there is a machine existency? So the machine is doing some operations and all, so that particular part I can able to tell it only using this as a plate element. And one more thing guys here, please be observe it very carefully when you are doing this particular cross sections and to the slice segments, that when you are going it, okay, remember that you are working on a slice actually. You are working only on one particular slice. So one particular slice in a sense that what you are doing it, out of this entire 3D, out of this entire 3D of the machine, that what we are doing it, what exactly it is doing on this particular plane, that means only onto the planar directions that we were capturing it, and we are going to work only on that particular plane what is happening. So that is what actually that we were trying to simulate in the 2D, because in 3D that we can able to do the complete process, but in 2D as we are working onto the planar directions, we are concentrate or we are focusing onto the place that where we can able to do the process and all, where the process is going on, that particular place only we can able to do that. So this is where we can able to do this. Do you have any doubts why we are providing the line contraction, and why we are providing the negative interface, and why we are creating a plate element? In these three, do you have any questions to me?
No.
Okay, you got an idea, right? Realistically also.
Yeah.
Okay, fine. So yeah, even to my experience, I've very less worked onto this particular tunnel things and all. To be honest, I can say no clients onto this tunneling thing, but I have a little experience when I was with Ramcat, just working with L&T for a few projects too as well. Okay, so this is all good, and those particular tunnels actually the way we supported is like passes of the animals in the national zoo parks or something like that. There is a road lying above the tunnel. There is a pavement above the tunnel actually, and below the pavement the tunnel is there. and the animals it has to pass from one way to the other way. So for that particular purpose, this particular tunnel it has been constructed actually. Okay, so especially onto the national parks, you can say that that particular space, one particular project that I have done. So this is where actually it helps you to analyze that particular things and all. And then with all these things, the reinforcements, if you see that there is a no reinforcements, that means we are not doing any kind of a grouting. It's not required actually. Okay. So this is where actually we could able to create these particular tunnels and all. Yeah. So now here above the tunnel that we have something called like building, but above this particular tunnel, there would be like a vehicle loading it is give following, and the distance between these two is hardly around some 2.5 to 3 meters and all. And there are some quite interesting projects also. I'll try to figure out the publication papers where I work with CRRI, and that's where the first thing. There is a railway track above over here, and below that there is an underbridge passes that we need to construct it. So for that also that we need to make these kind of tunneling operations for this, and that's where Dr. Jaipal Singh is the guy who worked on it, and he introduced this particular groutings to as well as a challenge, where the train is running lively. Actually, there is a live load happening onto the track, and that particular point of time, the tunnel constructions also need to be go hard, so without disturbing those particular track work. So for this, actually, the initial grouting helps that we have taken it and then could able to do that. And that particular problem also have just simulated in Plaxis, and which shows some good results actually. You can say some 86 to 87% of correlations with the physical test results. Physically, what's happened to that to this, actually, we are good for that. Okay, so now this once the tunnel constructions everything is done, and we got to know the importance of like what we are doing for the line contraction too as well, and we just go for the meshing. You all know that why it is going in a green color. That's where like mesh concentrations that you are increasing at that particular points, and then you're going for the flow conditions where that you have like global water conditions and all. Yeah. Now if you see these things, the water conditions, and if you just go for these particular things and all, there is only the deep clay over here, and you can see this is a deep clay and this is a deep sand. But if you just see, this is also deep clay and this is also deep sand, but the color indication here in the flow, it is indicating that it's as simple as that the water there is a tunnel constructions, we are going to remove something to the geometry is a suggestion it is going to give that. Okay, don't worry about the color changes there. And now moving on to the stage construction, this is where actually you can able to go. So yeah, by clicking onto the initial phase, if you go for the flow conditions, the suggestions it will not give. But when you just go for the tail void conditions and all, where you are going to remove the water, that's why it is going to show these conditions. Okay, so that's why I told don't ignore those particular color things and all, because we are going to address them into the stage construction. So now into the stage constructions that you have to see. Now tell me guys whether I want to take it as a KO procedure or a gravity loading for this one. Can you please
Gravity,
suggest like this is a gravity or a KO procedure?
gravity loading, I think.
Okay, one says it's gravity loading. Vivek says it's a gravity loading. Bharat?
Yeah. Hello.
Yeah, it's a gravity loading or a KO procedure.
Think also gravity load like a embankment.
Okay, two says it's a gravity. Prabhakar sir?
Yes, sir.
This is my initial condition of my problem. So do I
Okay.
need to go with a KO procedure or it's a gravity loading?
What type of loads are applied? Basically, it is the
It's an
self
initial
weight of the
condition.
files and the soil.
No weights, nothing. I have only the soils here.
Mhm.
So now in this case, I have only layer 1, layer 2, layer 3, layer 4. 4 layers of a soil that I have it. Nothing is
Gravity,
applied.
self weight.
Okay, Ashok.
Unless there is a let us say pressure from the bottom, uplift pressure, the only pressure is the self weight.
Okay, so what is the difference between the gravity loading and KO procedure?
I think
Let me-
while driving, if there is a structure present or anything present above the layer, topmost layer, and it needs to be considered in initial conditions, we take it as gravity loading.
Okay, what? No, I think. Let me open up the presentation. If it is having, then we can look into this too as well. Okay, that's good. I hope you have seen this particular presentation, right?
Yes.
Okay. So this presentation is not new for you too as well. So the slides are also not new for you. So what is this? When the initial conditions, why I have taken KO procedure here, when I have taken a gravity loading? First, tell
When
me.
the geometry is full, we can consider it as KO procedure.
Okay, what happened here?
Remove
What made
construction.
you to choose this as a gravity loading here?
Yeah.
The building.
Hmm?
Under
What
impulsion,
made
it
you
is
to
a
choose this
self
as a
weight.
gravity loading?
No, actually it
Presence
is.
of building.
Now tell me, it is a gravity loading or a KO procedure?
No, KO procedure actually.
So this means what I'm telling is not impacting you properly, or you are not doing the sufficient
No,
practice.
we are not doing sufficient practice. Well,
Remembering is also important.
This is a gravity loading, na, because there is a presence of building.
In the initial conditions, we don't have any buildings. We am considering only the soils. See, next stage, I'm going to do the building.
But if we were doing a borehole here and a building is already present, then we have to take it in the initial conditions. No?
See, I'm going to construct the building. That's what I told you. See, you have to see this. I'm showing you the image. When you are looking for this, you can see this. I have not activated any other buildings or nothing and all. Assume that everything is in gray out color.
yeah.
For this particular condition, I'm asking, okay, maybe in your assumptions that you have some building, all those blah blah things, okay, that's fine. In that particular cases, you can go with the gravity loading. But in this case, I'm asking it. In this case,
So,
I clicked on the initial phase. You have to observe all the things too as well.
excuse me. In this case, we have to analyze the tunnel in the presence of the building, or we have to analyze the building in the presence of tunnel.
See, I'm analyzing that in the presence of the building, I'm analyzing the tunnel behavior.
But then, if you are analyzing in the presence of building, so the gravity loading, you must be considering that, na? Because
No,
you said
see,
building
I'm
already
not
present.
straight away. I'm not coming over here. I can go in a multiple phases. So first is my soil layers. I have it. Next, I can construct the building. After that, I can start doing my tunneling construction. So in this particular cases, the initial phase, I have only the soil layers, right?
Yeah.
I thought that there is a presence of building, and after
There
that
is
we
a
have to.
presence of a, see, I completely agree with you. There is a presence of a building, but I'm showing you the image. I'm not asking you the problem statement, right? I'm showing you the image, and in this image, everything is in grayed out color. And in this particular cases, what procedure that you need to follow? See, in the image, I clicked only on the initial phase. So when this question rises to you, immediately that you have to look for this model explorer. Is there any building is activated here? No. If the building is not activated, then it is simply KO procedure. If the building is activated in condition, then you have to consider that as a gravity loading.
We have to do the modeling na. It is already a modeled structure. If we are modeling it, we might have used the gravity loading for that. And in that case, we have checked all these the building in model explorer for this.
No, Vivek. See, we have built all the structures necessary, whatever the construction structures and all, whatever the structural elements with the tunnel building, everything that we have constructed in the structures module. But coming to the stage constructions that you are going in a realistic world. In the realistic world, first I have only the soil layer. Next building is going to come. After that, I'm going for the tunneling process. Look for a glance, forget about the problem
So
statement. When I show the image, here the activated things are only the soil layers. Activated things are only the soil layers. Building is not activated here. If you would like to really make a smart statement, then you can say to me like, by assuming that building is there, I can go with the gravity loading. Without a building, I can consider that as a KO procedure. If you would like to make a statement like that, I was completely happy and I was with you too as well. Just by assuming that there is a building already, you're good to go with the gravity loading. But here the building is not yet activated here. Building is not yet activated here. And to the top layer of a surface, it's already a KO position. I'm telling you this why? Because you should not confused when you are really doing some particular problems, and don't try to activate all the things in the initial phase itself, which is a very bad practice. So to maintain a good practice, try to make the very basic, the very virgin things into the consideration during the initial conditions, and later on you can start doing those particular other activities that which will not impact your solution. Okay, so maybe you are not going for the complete analyzing. So in this particular cases, what is the priority? When there is a no tunnel, when the building is constructed, this is the deformations of the building. When the tunnel is coming, this is the deformations of the building. In the presence of the building, when we are doing the tunnel constructions, what is the tunnel deflection that is happening and all? Okay, so the problem can be assumed at any state, but I'm so happy that still if you remember these particular things and making your statements, then that is good. Yeah, I agree when it is a gravity loading, when you assume that building and the initial stages and all. But when there is a no building, it's a plain soil, then you have to go with as a KO procedures. Okay, so
Yeah.
maybe assume that here I'm not considering the building. Now, which procedure that you will follow?
Sorry.
Assuming that I'm not considering the building at all over here. Now, it's a KO procedure or a gravity loading.
KO procedure.
Okay, fine. Yeah. So try to so the now the tip for the day, you can make a note. Try to solve the problems with the KO procedure to the maximum extent that you can. You can. If it is not possible, then you can go with a gravity loading. This tip will help you to get the more and more accurate results, because when you go for a KO procedure, it follows the Jackie's formula 1 minus sine phi, and necessary soil strength it will take in the initial conditions and all. So it's a pre-stress embedded in the soil will be considered it. If you go for a gravity loading, it's all the gravity is just about the weight against to the gravity, how much weight that you are building it up. Only that particular weight management it will do that. Okay, so tip for the day: try to analyze the problem to an extent with the KO procedure. If not, then you go with a gravity loading. So that's why with default procedure always we can say it as like a KO procedure to as well. Okay, now in this actually they went with a KO procedure. Now if you see that the geometry is only activated and only the soils are activated. Okay, and if you go for the modal conditions in the water, actually which are default, it is going to be activated. borehole water level I'm going it. If you would like to go for the deformations, if you see that, this is the boundary conditions that I'm capturing it here. Okay. Now I would like to construct the building. That is where, like in the first phase, so that's where I inserted the embedded beam rows, and now it is being highlighted. See this. I've inserted this embedded beam row, or like you can say it's a piles. After that, I created a plate element that which is representing here the building actually. So for that particular reason only, if you see this, I've just activated this particular embedded beam rows, and then I've just activated the plates also. If you just go for the plate 2 I have just activated. Plate 2 is nothing but a building. Okay. And then next is actually my tunneling process that I would like to start. Okay. So what will happen? What will happen as we assume that before, no, if you include this particular piles and as well as this particular things are also into this initial phase, two things may happen it actually. One, we are not accurately capturing the deformations after the constructions or because of the self weight of the constructions. What is the deformations, predefined deformations are happening onto the soil? We were unable to capture it. So this is the reason there we may lose around some 5 to 10% of the accuracy in the end results. Point number one. So the predefined deformations here, we were losing it. The predefined deformations, we were losing it. Because of this, actually, we may lose the pre-stress or like the predefined deformations we may lose, and the end results may deviate around some 5 to 10% from the accuracy and all. So this is where actually the point number one that you need to remember this. Point number two, actually, because of this particular self deformations are happening on this particular soil regions of the construction, there is a high pressure, chances are there is a high pressure embedded in this, high pressure embedded in these particular soil zones. Because of the compression of this, actually there might be a chances of a high pressures embedded on this. As the soil is pushing in this direction, there might be a chances that there is a huge amount of pressure there it is. So we will lose that particular pressure also. The pre-stress, you can say, or the pre-stress, we were losing that particular things. So which makes your tunneling process very simply, like as you have taken a soil sample, with the similar soil samples, you are going to do the tunneling process, and which may avoid so many challenges. But if you do this particular, avoid that constructions of the building in the initial phase, and you constructed a building, and because of this particular building, the pre-stress involved in this and the extra challenges over here in this particular soil, also we can able to capture it. So this makes our problem like more and more realistic in nature. You got my point? Why actually in the tutorials also they have been separated from the initial phase to the building phase, and why as suggested that try to go when the structural elements are involved, try to go ahead with KO procedure maximum of the times. Okay, so now the question comes to you, when I need to go for gravity loading, if all the cases actually, if you consider this, when I would like to go for this gravity loading or not. Okay, so I will come to that particular point too as well. I don't know how far it is. I'll just like to add up this. See, there is a site actually. There is a site. So in this particular site, you have already done the excavation. You have already done the excavation. This particular site that you have already done the excavation for certain amount of a length, and now because of some few reasons that you left it, maybe the construction is not started or you left that particular thing, and as you left that particular thing, now what will happen is like there is so many environmental changes happen. So there is a moisture content, it is happening onto this, moisture is being added, and there is a rainfall it happened. Because of this, actually the water pressure has been added over here. Okay, so there is a rainfall happened and the water pressure is also added over here and all. Yeah. Now there is a requirement from the site saying that, hey guys, I have already excavated some region and now it has been fully filled up with some water. Now my idea is to dewater this particular thing, and again I would like to reconstruct my particular construction. So they will come and ask you, is it good? I can consider whatever the procedure previously, is it is good, or do I expect any changes? Okay. What happened to your borehole conditions when you captured the soil in the initial conditions for the sampling before the excavation? Before the excavation, when you captured the soil and you're sending it for the lab and you got the material properties of the soil. After the excavation, when your site is exposed to some environmental changes, and still if you are using the old material properties, which is not so relevant, which is not so good at all, but you can't tell to the site, go back, take the soil samples again now after when the water is dewatered, or like after a few days, how it is there, you take a sample. You can't ask the lab guy to again retest on those particular things and then do all these particular changes. It's not possible. So now simply to implement this kind of a scenarios, that what I can do is like, I can just go for this particular initial material properties itself with a small changes. If it is happening it, I can consider this particular changes if by chance if you have the material properties. But if you have only the initial material properties, first do this, first do only this one, go with the KO procedure, and then attach this, simulate what happened in the site for these many days. That's maybe like you fill with the water and then remove the water. You fill with the water and stay there for 20 days, and then you're removing this particular water. What happened to this particular site? You can analyze that. Over that, you can start building the construction activities. So that's where actually you have to be like a more realistic, and you have to be like a more confident on what is there. You guys got my idea when to choose a KO procedure and when to choose a gravity loading and all.
Yes.
In this cases, if you just directly go the gravity loading, you may not able to consider all the things what happened in between 20 days of time. Let's assume that what happened, we can't able to capture those particular things. So this is a small example that I tell you, the realistically, but there are so many parameters that which may influence you on that particular things and all. Okay, so that's where that you have to be like a very focusing on that. Yeah, so that's where the first thing actually I've just activated the building and all. Next is the tunneling process that I need to go. So for the better understanding and easy remembrance, that I've built one particular slide for you guys. That's where the tunneling process, you can see this. So it's a TBM, tunnel boring machine for 2D, and the tunnel procedures and all. So what you need to do as a first procedure, inside whatever it is there, the soil, you select that particular soil and you make sure that the water level is in the dry conditions and all. So that means you are removing the water in that particular soil. So whatever the groundwater level conditions is there, on that particular soil that you need to remove the water, dewatering should happen. After that, your tunnel boring machine that you need to activate it, the one in the red color, this is called, we are calling it as a plate elements. So you need to activate this particular tunnel boring machine as a plate element. After that, again, you can just go for the line concentration, because as the tunnel boring machine is moving forward, so there might be sliding of soil may happen it, or like the deformations or settlements will not be good. So that's why we need to go for a line contractions. And after the line contractions, what you need to do, you have to deactivate the tunnel boring machines. The water conditions of the clusters will apply some kind of a pressure actually. So this is where the line contractions of 0.5 pressure. So that particular water pressure that you need to apply. So that is nothing but your grout pressure, we can say. That is nothing but our grouting pressure, you can say that. So This is how actually the arrows will be there. I'll show you that how it is coming over there too as well. And the next actually what you have to do, so deactivate this particular grouting internal pressures that which you have created it, and activate your concrete plate. So that's where which in the video that I have shown this prefabricated cement blocks or a concrete blocks that we are going to get it. So that particular thing, that particular plates are nothing but our final lining that we need to activate this particular thing somehow. Okay. So this is a simple tunnel process that I have just built for you. So first thing is like you have to deactivate the water. Second thing is activate the tunnel boring machine through a plate elements. And then is like line contractions. And then you have to deactivate the tunnel boring machine. That is nothing but you are deactivating the plate element and you are applying a grouting pressure. And after that, deactivate the grouting pressure also and activate the plate elements or not. So this procedure, what we need to do, you got an idea? If you say yes, then I will take you to the software and I'll show you the same procedure.
Yeah.
It's clear.
Okay.
Okay.
Fine. Now moving on this. So the first step is like the water level need to be a dry conditions and all. That's where in the tunnel boring machine, when you select this one, so the first thing I need to select these particular two clusters. I need to select these two particular clusters. When I select these particular two clusters, actually, initially what will happen? The water level, it is there, right? So in this particular things, if you select this one here, if I would like to dewater this particular thing, conditions, global level, right? So I can just go and choose it as a dry. So in the similar cases, I have selected the soil over here and I make this as a dry condition. I selected the soil over here also and then make it as a dry conditions. And then as the soil need to be deactivated, right? So after dewatering this, I need to remove the soil too as well. So I can just right click and deactivate these two particular soils. So that's where I can able to deactivate it. After the water removing everything, I need to activate the tunnel boring machine, right? So the tunnel boring machine that I need to go, and it has been made as a plate element, right? So that is where actually the plate element one, it has been activated. Now you see this. Now you see this is in a grayed out color. If I activate this particular plate one, this is where my tunnel plate, it has been activated in blue. As I have just activated my particular plate elements and all, I would like to activate the interfaces also. That's where like the interfaces also have been activated because the interaction to the soil and all. So now you remove the water, you activated this particular machines. You remove the water and as well as you remove the soil too as well. The line contraction that you need to apply. That's where like conicity, you can say that. So the TBM conicity, we can say that. So the line contractions. So if you just click on this one, in the tunneling, that when you just go over here to the tunnel, if you just go for the edit and to the properties segment, if you see this, I have just created the line contractions with the 0.5%, right? Tunnel contraction. So that particular feature in the stage construction, now I'm coming over here and I'm just simply activating this one, line contraction. So when I just go for the TBM machine, the line contraction is not activated. When I go for the conicity, I'm just activating this particular line contractions too as well. The line contraction, I have just activated it. Now I'm just going for the interfaces to got activated and the embedded beam rows or for the building, all the time the building, it is in activated conditions. Okay. Now I've just activated the line contraction too as well. As I said to the procedure, so the line contraction is there. Now I just need to go for the grout pressure, where I would like to activate this particular water conditions of the cluster to be and apply. So the pressure that I need to create it. So tile void grouting is what is my step I'm calling it, but you can just name it whatever you want. So I'll just click on this particular thing. When I click on this particular thing, so what is I told here? Deactivate the tunnel boring machine. First thing, when I go for this particular step, I deactivated my tunnel boring machine. That is a plate 2 that I've deactivated it. So when there is a no plate, there is a no interaction also. I've just removed the interaction too as well. And there is a no interactions, there is a no soil contractions too as well. So I just remove the soil contractions too as well. And if you just select these particular clusters, if you select these particular clusters in this region, so, and this is where actually previously the water conditions are used it as a drained condition, right? So when you just go for the tunnel boring machine, here the water conditions for these two clusters I selected, it's a dry. But to the tail void conditions, these two I've just selected it. And the conditions, user defined conditions that you need to select. And then you have to apply a pressure of a 230 kilonewton per meter square of a pressure is what that you are applying. So that is what is actually the grouting pressure that you are applying it over here. The pressure will act like this. Okay. So after this, actually, you are done with the two as well. So now the next simple step that we are doing it is here. Sorry, mouse. Yeah, the next simple step that you are carrying here is like lining installations. So for the lining installations, what I told, deactivate the grout pressure and activate the concrete plate element and all. So that's where when I just click on this one, if you select these two particular soil conditions and all, again this is becoming a dry, and the lining is the final element that we need to activate it, right? So that's where actually the final plate element on this activating these particular plates. Okay, and this particular final lining that I've just been activated, and I've just activated the interfaces also, and there is no other points on that. This is how actually the construction procedure it is going on. Okay, just for your convenience that what I will do again, delete this, and I'm deleting all the things actually here. I'm deleting all the things. Now this is an initial phase. We know that only the soils are there, so I just consider this as a KO procedure. Now I'm adding this and I'm naming these particular things as a building. I'm naming this as a building. So just give OK, default, everything is default. Now the building actually I'm doing it. So first I would like to activate my embedded beam rows, and then I'm activating my plate 2. That is nothing but the building actually. Okay, now I've just activated this building also. The next is like, so TBM, you can name anything like a TBM that I would like to activate it. So just give act as a TBM. So when the TBM it is coming, the first step I need to go is like, I need to select these two, and then to the water conditions, I would like to make this as a dry condition. So that means I have removed the water from that. After removing the water, again, I need to select these two, right click on this, and I've just removed the soil too as well. After removing the soil, that I need to activate my tunnel boring machine. That tunnel boring machine, I will be activating it as a plate element. So I'll just click on this particular plate element. As this plate element is on, there is an interactions between the soil too as well. So I need to activate my negative interfaces also. This is what actually that I have done in my step 1. So I devoted this and then I activated this one. So the next one is like a tail grouting, you can say that, or like for your better understanding, you can just mention it as a line contraction. And say this as a line contraction. So just you activate the line contractions. Now in this actually, you just need to go for this line contractions that you need to activate it. That's it. Line contractions that you need to activate these things and all. So once the line contraction is got activated, so next you have to go for a grout pressures and all. So you just simply add these particular things and then you're calling this as a grout pressure. So just make it as a grout pressure default, all remaining are default. So the grout pressures. So you need to apply this particular grout pressure. So what you need to do, deactivate the tunnel boring machines and water conditions, apply the pressure actually. So I'm deactivating the tunnel boring machine. And then when I deactivate this, there is a no interfaces also. And there is a no line contraction too as well. And if I select these two particular soil clusters, here I need to go for the water conditions. In the conditions, you can mention it as a user defined. And in the user defined conditions, you can just go and provide these particular values and all. So it is minus 230 kilonewton per meter square of the value. That is what we were trying to apply on this. That's it. That's where that you have applied the crowd pressure to as well. After activating the crowd pressure, that's where the final one that you are going to do is like lining installation that you are doing. So you just need to install this particular lining. So the lining installations, when you would like to do the lining installations, so the, as I told you in the procedure 2 as well. So deactivate the crowd pressures and activate the concrete plate elements and all. Okay. So the first thing is like deactivate the routing pressures. So I just need to select this one, and then instead of the user defined, again I would like to make it as a dry conditions, and then the final lining it need to be get activated. So I'll be activating the lining, and then I would be activating the interfaces also. That's it. So this is what the tunneling procedure that we have done for this. Okay, now you can just go simply calculate this one. Do you feel it is simple?
Looks like simple.
Practice makes you more simple actually. Okay, assume like what you are doing realistically also, that also makes you very simple. So to my better knowledge and to make it more comfortable and not to forget the procedure, I've just made a slide for you too as well. So you already have these things. If you are not, in our wiki page it's also there. You can able to download this image and you can start doing this. Okay, for your better and better understanding, that if you want, I can do one small thing. I'm just giving you an idea so that you can keep it with you too as well. So if you know this, you can able to do the tunneling process at any point of time. Okay, so now it's all done. The problem, everything is done. So let me go for the view calculations of the results. I'm just going to view the results now. Now you can see this. So let me expand this. You can put Ctrl+2. Yeah, this is where actually you can see this. This is your initial phase. And then it's like the building. You're building this. Because of the building, there is a settlement. If you go this as an initial conditions, you are losing all this particular deformations, all these things, pressure. Okay. And then the TBM I have activated and I remove the soil too as well. And then the line contractions that I'm going here. After the line contractions, the grouting pressure that we are applying it, and to the grouting pressures that we were going for the final lining installations. Okay. So now if you would like to see what's the deformations happen onto your tunnel and all, you just double click on this one. Now you can see what has happened to your particular tunnel and the shear forces and bending momentum diagrams of your tunnel also you can able to see. This is your bending momentum diagram, this is your shear force diagram, and you can able to start validating these particular things. Okay, so this is how you can able to do this one. So the procedure is simple, that if you just remember this one, I'm damn sure that it makes you more comfortable when you remember this particular image. So make this image when you are working on a tunnel, please remember this image, that we have set an image, and then you can follow the procedures.
Okay.
Okay, so yeah, whether I'm good with the tunnel too as well, but if you guys have any doubts, feel free to reopen this, and then we can able to proceed that dimension. Okay. Good. So there is an excavations of an NMTL tunnel actually. This is quite simple and easy problem. I would like to give you guys to do this as a homework, but not now. Let's do this particular example and come back to me, and then I can able to tell you that. The next is like dry excavations using a tieback wall. This example also you guys can do that because you know how to dewater the conditions right now that we have seen it here, and you guys already know how to construct a wall also. So but still I can show you those particular examples too as well. Okay, and then slowly the seventh one I'll just give you as an example to dry construction using a tieback wall of ULS. And the constructions of a road embankment is the next important problem that we will see in the coming class of Friday, or to the nearest classes on Monday that we can see that. Because if Friday, if you need any other doubts, that we can able to work on this excavations of an MTL tunnel too as well. Okay. I hope this makes you comfortable. Please practice on this and come back to me. Let me go. I'm just stopping the recording, and let post if you have any questions.